Okay, the first class I'll talk about is systems analysis. We did not use this book, but we used a similar book. I just bought this book for about $10 on Amazon. We talked about what is a system, what is a linear time invariant system. There is the singularity functions, the unit step function, the unit impulse function, very important function. We went to Fourier transforms. There's a table of Fourier transforms. Those are very important in analog communications. Laplace transforms. There's a table of Laplace transforms. And then we spent a lot of time on transfer functions. This class is electromagnetic radiation. Lots of vector calculus, coordinate systems and transformation, Cartesian coordinates, cylindrical coordinates, and spherical coordinates, and how to change from one system to another. Del operator, a very important operation in vector fields. Divergence of a vector, and a divergence theorem. Curl of a vector, and that's how you find the curl of a vector. Okay, more on vector fields. Coulomb's law, Gauss's law. Electric fields and magnetic fields are vector fields, so that's why this book is basically a book on vector calculus. Biot-Savart's law, that's related to magnetism. Maxwell's equations. Okay, this is the class on control systems. I bought this book, Control Systems Engineering by Norman Neese. In class, we used another book by Ogata, Ogata, but that's a really hard book to read, so I got this book. Yeah, there's your typical block diagram. Here they're reviewing partial fraction expansion. That's a very important technique for solving control systems. Then there's theorems about Laplace transforms. Laplace transform used to solve a differential equation. Transfer function used to solve this RLC network. Yeah, there's the transfer function. The S is just means a complex number. Block diagram of a series RLC network. And of course, control systems can also be used for mechanical systems, as shown here. This is another technique called state space to solve control systems problems. Here's your block diagrams. There's a block diagram with feedback. And there's the basic block diagram, input, plant and controller, output, feedback, and then the error signal. Okay, is your control system stable? Then there's techniques to find out if it's stable and the response time. Creating a Ruth table for to find out if your control system is stable. Then here's a root locus. Root locus is a way to draw a graph of a control system. Yeah, here's some typical root locus problems or root locus graphs. This class was analog communication systems, AM and FM radio. The book that we used was Modern Digital and Analog Communication Systems by Lothy, but this is a very difficult book to read, so I got this book from Amazon, Analog and Digital Communication Systems by Martin Roden. Okay, we start with the, let's see, start with the Fourier transform. There's the singularity function again. Sinc function, that's a very important function. The impulse function. Convolution, that is a really hard concept to understand. I had problems with it. Okay, properties of the Fourier transform. Modulation theorem. Okay, amplitude modulation. And there's the modulation theorem. How you use a carrier wave to transmit a signal. There's a Fourier transform of a AM modulated signal. Yeah, that's called a double sideband suppressed carrier amplitude modulation. And then different ways of modulating a signal, different ways of creating an AM signal. And then how do you demodulate an AM signal? How do you get the message out of an AM signal? Okay, block diagrams again. And then we went to FM modulation. Yeah, frequency modulation. Narrowband FM. Wideband FM. This class was electric machines, the first class in electrical power. We started with 3-phase circuits. Okay, then we went to introduction to magnetic circuits. There's a simple magnetic circuit with flux going through an iron core. Iron core with an air gap. Analogy between an electric circuit and a magnetic circuit. Another circuit with 2 air gaps. Next is transformers. And then finally, electric machines. Schematic of a simple 2-pole single-phase synchronous generator. This is 4 poles. Elementary 2-pole cylindrical rotor field winding. Okay, thanks for watching. I hope you found this interesting. If I get more than 5 views, then I'll make another video with more books. Have a nice day.